Okay, Taylor.
And Keith, want to do just a quick test to see if we can share your screen, okay?
Yeah. Okay, I'm sharing my screen now. Can you see my screen?
See it?
Cool. Did you see the change, right? When I'm changing the tab?
Yeah.
Great. Audio levels are fine?
Yeah, sounds okay.
Nice. So I think
Yeah,
we
guys, starting in about 10 minutes.
Yeah.
Coming.
Okay then. Okay, guys, I think it's time for us to start. It's 11 a.m. at my place, CST time. So my name is Ankit Khare. I am an AI technologist / head of content and developer relations at Abacus.AI. You all can type a brief intro about yourself if you want in the chat box. So for maintaining coordination, we have, for the time being, muted you all. But yeah, at the end of the session, you would get a chance to ask any questions that you might have. Feel free to type in your doubts in the chat, and I'll take them at the end or perhaps in the middle if needed. Cool. Welcome, Ron. Okay, so without further ado, I'll start the first part of the session, which is a talk on deep learning. And then after that, we will dive into the demo session where we will be training a predictive model, basically a regression model using Abacus.AI platform. And we'll utilize everything that we have discussed during the talk while going through the demo. So you all will be signing up for the platform and then walk through the entire thing with me. Okay, so let's start with the talk. Let me share my screen real quick here. Okay. So before that, I would like to share this with you all. Zoom controls are popping in the middle. So this is the link to this Colab notebook. It has all the necessary resources that you would need for the purpose of this demo. For example, this is the sign up link. We'll use that to sign up for an account at Abacus.AI platform. These are the data sets that we'll be utilizing for training the predictive model. This is the slide PDF in case you need to refer to the slides that I'm going to be sharing with you. And this is the public reference for the same data sets that we have here. It's from Kaggle, as you can see. So you can go to the link and then see the domain if you would like to know more about the data and the various columns that are there and where it came from. Okay. Cool. Hi, Sohan. So I see a variety of people from very diverse backgrounds, which is very nice always to have. So I'll make sure to cover like everything at various levels of depth so that everybody would be able to understand and comprehend. Oh, man. So in case somebody is not muted, please mute yourself so that other participants are not disturbed by the background noise. Okay, so today's title is Train End-to-End Deep Learning-Based Predictive Models Using Abacus.AI. So as I already told you, after the talk, we will be training predictive models end-to-end. That means we'll be uploading those data sets that I just showed you. And then after that, we'll be doing some feature engineering on the uploaded data. And then finally, after producing some useful features, we will be training a model and then we will observe how good of a model we have trained by using some evaluation metrics. And then finally, we would be using our prediction dashboard to see the generated predictions. And then we will also go through some of the other things like batch prediction. So that's why end-to-end, that's what actually means. Like it's a very familiar term for people who are deep into the ML world. But yeah, I would want to make sure that everybody understands these terminologies. And predictive modeling, so anything that is concerned with identifying patterns and generating some insight using those underlying patterns is kind of termed as predictive modeling in the ML world. So basically here in Abacus.AI on Abacus.AI platform, we have a specific solution called predictive modeling. And then we have regression and classification problem types that are addressed under this predictive modeling solution. So today we'll be training a regression model actually. So as I said, we offer a variety of solutions like classification, regression, recommender AI, forecasting and planning solutions. And now anomaly detection is one of our latest use cases or solutions, which comes under the category of unsupervised learning. So in machine learning, there are two types of algorithms. One is supervised machine learning algorithms, and second one is unsupervised learning algorithms. So on Abacus.AI, the main focus is tabular data because in industry, most of the data sets that we encounter are in the form of tables. Although in the world of academics and academia, as you know, like vision and language kind of unstructured modalities are kind of really popular. And most of the papers nowadays are focusing on them. So we are also coming to that edge, to that spectrum. And we are also providing unsupervised learning For example, in our anomaly detection use case, the underlying algorithms are basically a form of unsupervised machine learning. To be more precise, it's an autoencoder. So yeah, but today's topic is not that. But someday we'll take a workshop, and then I'll be very glad to explain you about that use case as well. But for now, our focus is this bold one that comes under regression problem type, which is predictive modeling. So let's start with a quick intro to deep learning. There might be some of you who come from not a machine learning background. So I think it's necessary to explain a bit about what deep learning actually stands for and what it implies when I say deep learning. So machine learning is a broader set of algorithms, and deep learning is a part or subset of machine learning, which deals with something called artificial neural network. The idea is inspired by the neural network that we have in our brain, but there's a huge argument whether it really depicts that neural network in the brain or not, and a lot of people would not agree on that. So I would not get into the specifics of what my take on it is, but yeah, in short, I would just like to say that there are a bunch of artificial neurons, the small entity, like the smallest entity in an artificial neural network, and then these neurons are connected together, and then there are signals that are passed between these neurons, and then they kind of collectively learn to find some patterns using the data that is inputted in these neurons. And finally, the output is something that we utilize, that we gain from some business value or some other kind of values, like some sort of intelligent predictions. So as I said, most of the machine learning in today's world is targeted at deep learning. If you see the statistics, you will know most of the papers that come out are somehow connected to deep learning. Modalities might be vision and language or tabular data, but yeah, they're somehow associated with deep learning. I mean, under AI and ML papers, I'm talking. So yeah, that's why we are also taking advantage of this fact that all these latest advancements in the field of deep learning can be incorporated in our systems. So that's why whenever something new pops up, we try to go through those papers and then incorporate them in our technology stack. So we are, as I already briefly mentioned, an AI, a deep learning first company, and all our technologies are somehow utilizing deep learning based technologies as the underlying algorithm. So with this, let's dive a bit deeper into the various concepts that are needed in order to understand today's demo. So basically in this slide, I have included everything that will be needed almost to understand the demo, like data splitting, dropout, batch size, learning rate, AutoML, ensemble averaging. Even if you have a superficial idea of what these terms stand for, you would be good to go to understand the demo to a good extent. And I'll be explaining this a bit deeply, one by one. So let's start with the fundamentals. Train, validate, and test set. So it's kind of easy. You have an original labeled data set, like the one we saw in that Colab notebook. And now what we want to do is split this data set into 2 or 3 parts, basically 3 parts. On Abacus.AI, today, we're not going to split it manually because the system takes care of that internally for us. But yeah, we should be understanding that what's going on behind the scenes to an extent. So that's why it's important to understand what data splitting is and what these trains and validation and test sets are. So test set is where we evaluate the trained model. Train set is where we train that model. And validation set, so as you see, there are a lot of components within a neural network, like these neurons that I briefly mentioned. There's something called batch size. There's something called learning rate for those neurons. There's something called dropout rate. So all these hyperparameters, that means like tweakable or tunable parts of the neural network, they need to be adjusted for the best performance. So we need a set of data points, which we call as validation set, in order to tweak these hyperparameters well. Because if we If we tweak them on training set, then they will be biased depending upon the patterns that they see in the training set. They'll get biased. And then when some new data comes in, they might not be able to generalize well to that new data. So the entire scope of machine learning is how well the model is able to find the patterns in your data. And for the model to be able to find that patterns well, it's necessary that it doesn't stick to some particular data, but actually stick to the pattern itself, not the data point. So for that to happen, for this generalization to happen, we need to we apply some sort of methodologies like this splitting, like this validation set, where we keep some part of the data, maybe 10%, and then we kind of see what are the best values of hyperparameters that gives best results on this part of data validation set. Sometimes we also like revolve, like take, it's called cross validation, where we revolve, like where we, let's say 20% of the data set we have kept for validation, 80% for training. And then we revolve this 20% again and again, like take different 20% from the training set, and then again a different 20% from the training set. So that the patterns always keep changing and the model is able to generalize. So the idea is generalization here. The whole idea is how well you can generalize. And the idea of test set is to make sure that finally, when you have gotten a trained model with all the hyperparameters tweaked, then your predictions, they are of the top-notch quality. And the only way to make sure that they are really valuable is to feed some new data that the network has never seen and see how well it performs on that entirely new data, right? So that's why we take this test data set. We never show this data set to the model until at the time the model is fully trained. So the model at the time of training has never even saw this data. So whatever predictions we get, they're like a reliable way, they act as a reliable way to evaluate that model. Okay, so now I hope that you understand this very important part of fundamental of ML. Now let's move on to the functioning of a neural network. So mathematically, a neural network is a function approximator, which means that for every data point that we give it, the whole, basically think of the whole data set as like something that can be resembled by some sort of complex function. Generally, the function is real complex. In this example, though, it's not. It's a simple parabola. So for the sake of making it comprehensible, I've kept this function to be very simple, which is nothing but x equals to y squared, which is just a parabola. And now let's see how the neural network acts on this parabola and approximates this parabolic function. And then you would be able to get the sense of like how neural networks actually might be able to approximate even the complex functions. So what happens here is these orange points are the predictions by the network, but these are like the final predictions. At the initial stage, there's just some random point that is just outputted by the network. And what we do is we backpropagate. Like we have like a loss, like something called loss function, which is nothing but a function. Let's say let's take an example to make it clear. Let's say the point is here, the original point is here. So this is the distance between those 2 points, right? Which is the error. So the loss function actually depicts this error. It just denotes, it's a way to denote this error. So this error, when minimized, will lead to the final right or correct point, right? So at every point, the goal is to minimize this error. So what we do is we start with any random point. We have this loss function, maybe a simple loss function like this point minus this point and whole square of that. And then we try to minimize that loss function. And then when we have minimized it properly, we'll finally get to the original parabolic, something like really close to the original parabolic function, right? So this is the idea behind neural networks. It's a function approximator. So this is some code for people who have dealt with it. They can easily understand. It's a nonlinear function ReLU. So I'll not dive very deep into like what are the nonlinearities, how linear functions act, how deep neural networks actually are a stack of linear and nonlinear functions. But if you're interested, you can read. There's a lot of literature on YouTube and a lot of literature in the market on this. But yeah, the backbone, like the basic idea on how neural network is a function approximator and how it works is something that is really interesting and worth understanding in order to make use of neural networks or do anything with it. Okay, so now I've explained you about this loss function, but let's actually see how we minimize the error. What is the basic idea behind this error minimization and getting to the right point? So there's something called gradient descent and learning rate. So a gradient descent, it's just high school level math. You have a tangent at some point, and that always shows you the point of descent, the highest descent point. So you use the derivative to like kind of come to the original minimum point at every point. So in a neural network, as I said, there are like a lot of neurons. Every neuron might have a weight inside it. This is the loss function with respect to that weight. So we minimize this weight with respect to the loss function such that it reaches the right point. We use gradient in order to do that, right? So at every point, what we do is we find gradient, subtract that from the current value, come close to this, keep coming closer, closer, closer until we finally reach this point. So that's the whole idea of gradient descent. So learning rate jumps into this scene when, so think of this, like if there's a large gradient, then if you subtract that large number, then that large number subtracted might make this point go like this up there, and then like fly off like somewhere like this. So it might like never come to this global minimum point. So that's why learning rate comes into play, where you set some small alpha, like how much of this gradient would you want to utilize for this step at some particular point of time. So that's why learning rate is important to tweak or tune. So nothing at current position, you subtract the learning rate multiplied by the gradient, and that's how you get the next position. And you keep on doing that, and occasionally you will reach the global minimum. And then this is a very simple example where I'm just showing you using the one weight and one loss function on the basis of that weight. But for every neuron, think of that as a weight. There's something called a bias as well. So what you do is you just tweak that weight for every neuron, and you make this loss function like a complex function which encapsulates all of those neurons. And there's something you might have heard in your high school math called partial derivative. So the idea is, instead of this full derivative, now we keep on finding those partial derivatives. And that whole algorithm is called backpropagation, where the partial derivative is calculated and then it backpropagates. And then finally, you get to the right point for every such neuron. And the whole network gets tuned up to give you some sort of useful predictions. Batch size. So now when you put your data into the network, like these were the data points X, these were the labels Y. So it reads these input data points, it reads the labels in order to understand and formulate this function. So when you input this data, there's a batch size, like how many such data points would you input at one time? So that is what is called batch size. So there are two things to keep in mind about batch size. One is a large batch size is going to be computationally expensive. Second is, but it will be very useful in the sense that you could approximate this value properly because the batch size is large. On the other hand, if the batch size is small, then this approximation will not be that precise, but then computational complexity reduces. Now it's more efficient. So there's a trade-off that you would have to find where you are getting the best of the both worlds. Predictive modeling use case. So this is the topic today, right? Predictive modeling. So let's see what this use case is defined as. So it's nothing, on the platform, you will see there's this option called predictive modeling. I'll show you during the demo. What you need to do is just show the platform what your inputs are, what your output would be, and then the platform will do the rest for you. It's like just showing the endpoints to the platform. Like this is the data, these are the features, and then this is the output you want. Like for a regression, you might be, let's say you want to calculate life expectancy of a person. You have some demographics data, some disease data. You can like input that. And then finally, for that country or for that region, for those demographics, the system will give you the life expectancy. So that's what I mean by input and output. So now you understand predictive modeling. Let's go towards the accuracy measures, which is nothing but the metrics that are used to evaluate how good your model is. So for classification, so there are two things in predictive modeling. One is classification problem type. Second one is regression problem type. So for classification, these are the three key metrics that you would want to have a look at. Accuracy, precision, recall. A lot of you might have heard very famous precision and recall. These are very commonly used terms when it comes to classification. Yeah. Second one is for the regression model, which is WAPE, RMSE, R-square. So I would want to go a little bit deeper into these because today we are going to train the model, which is a regression model. So that's why this will be very useful to understand so that we could see how, so we would be able to read like those numbers, like a WAPE number, RMSE and R-square value. We'd be able to like evaluate and make sense of those values. So let's dig a little deeper. If you're wondering what this diagram is, it's just a screen on the Abacus.AI dashboard, metric dashboard. So after training the model, this is the model name. This is a version of the model. This is the metric, this one. So this graph is showing a correlation between target and column. So what happens is if your columns in the data set are highly correlated with the target, then the model gets biased. So that's not what we want. I already explained how the whole point of machine learning is to be able to train a model which is very generalizable, so that if your new data comes, it can generalize to that properly. So that's why you have to make sure that the columns and the target are not highly correlated. So this graph is showing how what are the most correlated columns, so that what you can do is ignore those columns and then retrain a new model, which will be better. So what you can do is just like click here, and all these correlated columns would be ignored. So this is a feature engineering step. So we would be looking at all this during the demo. Second is this model explainability, feature importance scores. That means what are the most important features that contribute the most towards the prediction that are produced or generated. So like you can see income, meals, these are total expenses. These were the most important features for some sort of prediction that was happening for this life expectancy calculation. Okay, so let's understand the metrics. WAPE, weighted absolute percentage error. So it has a very definitive mathematical form. So if we break down this into 4 steps, you would be able to intuitively make sense of that mathematical form. You have actual values, which is the ground truth. You have the forecasted values or the predicted values. So the model, in case of regression, predicts some sort of value for the target variable. That is what I'm referring to here. Right, so for each value, you have an absolute difference, which, as you can see, absolute difference means just the mod of actual value and forecasted value. So finally, when you will have this absolute difference for each point, you will sum them all. And then you will divide it, or it's just normalization, like dividing by sum of all the actual values. So sum of all the ground truths and all these absolute sums of the subtraction of the predicted values and actual values. So you can intuitively think of it as like some sort of like difference calculation, which is the error calculation, like how far is your value, predicted value, from the actual value. And then finally, then you normalize it with the sum of the absolute values. So it's like percentage calculation of the error, right? So WAPE is as the name suggests, nothing but a weighted mean percentage error. R square, coefficient of determination. It's also quite simple to understand if you just know what a dependent and an independent variable is. So the target column is the dependent variable because it depends on those features or the other columns in your data set. And the independent variable are those columns, right? Actually, I'm wrong. It's the opposite. So the independent variable is the class value. Oh, no. Yeah. So think of it as this. The class value of the target value in the data set, it's an independent variable that's determined. But the other variables like features and columns, they are the ones who depend. So they're dependent variables. So now that you know what is a dependent variable and an independent variable, we are ready to like make sense of the coefficient of determination. So, so think of it like this. In regression, you want to make sure that each feature that you're creating somehow is contributing towards the final result. So for that feature to make sense, this evaluation metric kind of determines or tells you how much correlation exists. So what percentage of this column is contributing towards that final prediction. So that's what R-square is. Like if you have a correlation between the column and the predicted value, then that means this is a good feature, right? And if it is not, then that means there's nothing that this feature tells you about the prediction. So that's where R-square comes into play, where you want those features that actually make sense towards the final prediction. So there are 3 basic steps towards generating predictions. One is data preparation. Second one is training the model, and finally deploying that model to get the predictions. So I explained you some steps in data preparation. I've already explained that. Model training, you already can guess. It's just training the model from the input. So once your data is prepared, you feed into the data, you feed in all the data, and then start training your model using the ML algorithm that you have chosen. And then finally, the model deployment phase, where once you have a trained model, you deploy it. That means think of deploying, like the process of deployment is basically utilizing the trained model. So there's a whole infrastructure that is required in order to generate predictions from a trained model. Like that trained model needs to be read, right? Like whatever that trained model encapsulates, that needs to be read properly. So that model deployment infrastructure is the one that reads the trained model and generates and helps in generating the prediction from it. Okay. To create custom production-grade deep learning-based system at scale, you need. So this is about scalability. Like in real-time industry environment, there's a lot that goes on into producing intelligent predictions. Like you need a huge stack of skills. Like you need data scientists, you need backend developers, you need DevOps, right? So these are entirely very like broad fields on their own. So a very collaborative environment where people coming from all these different fields working together to produce these to make this happen is needed. Make this happen in the sense like taking the data from the initiation phase till like bringing in useful results from that data from the conception phase, right? So that's what I'm trying to say. Like a variety of skills are needed in order to finally get intelligent predictions from the data that you have. Data prep can be very complex. So you might have heard like data pipelines. This word pops up a lot in machine learning. So data prep, sometimes data munging, data cleaning, these are just the synonyms of data prep. So all these steps are very cumbersome. Generally, machine learning engineers find them very boring sometimes, but then they really form the core of machine learning. If you can't prepare your features well, then you won't get useful predictions. Or even if you get predictions somehow from them, they will not be of such high quality as they could have been if you have engineered the features and spent some time doing that properly. So that's why I kept it here because we are today, we'll like work on some ideas on how to prepare the features well and how that can influence the prediction and make the metrics better, the metric values that I've already shown you, WAPE, R-squared, those things. And oftentimes these data sets can be very noisy, very incomplete, might have a lot of missing values. So the process becomes very tricky, this data preparation process. It's not easy at all. And the field changes constantly. As I said, the research activity in the field of especially deep learning is quite high. So the field moves really at a very fast pace, and it gets harder to keep up. So these are some of these challenges that are present in the world of generating predictions from ML models. Okay, so this is an interesting slide. So at Abacus.AI, we believe that this process of generating predictions from the data that you might be interested into should be very ubiquitous. So for people at different stages, we have made a system which can benefit all of those people at different levels. For example, developers and business analysts who doesn't come from a deep ML background, so they can also learn from the system. They can also make use of our system. So this forms like the first layer of this cake type thing, where at this first layer, those people can make use of the system. At this second layer, ML engineers and data scientists, they can also make use of the system. For them, there are some specific modules like advanced training options, which they can use, tweak those hyperparameters of the neural network that we discussed. And that way they would be able to customize the model and make it more efficient if they know how to. And then the bottom layer. So there might be somebody who really needs complete control. And for those people, they might have there's a solution on the platform, which is like giving them a plug and play environment where they can plug their own algorithm. So it's like a Docker, you provide them a Docker, or maybe like you provide them an environment that can help them bring their Docker and integrate, and then somehow make use of our existing machinery along with whatever they might be interested into. So this is something that I wanted to bring in so that you understand how this kind of modular layered structure benefits people at different levels, and how AI should be done in this world so that everybody at some sort of level of expertise can be benefited from it. And this is what you will see in the system. When we'll come to the demo stage, you will know like exactly what I was talking about. AI as a service, which again correlates to the same thing that I discussed here. So a wide range of people with little or no deep experience as a way to experiment, deploy AI models. Again, the same thing. So AI as a service means, let's say you have a web application or some sort of desktop application, and you are a software developer and you have developed some cool application, but now you have an idea of like empowering it with some AI ML technology. So that's where AI as a service comes in handy, where what you can do is use some API that are available for this service, and then utilize them for making your application intelligent. So this is what I meant by saying AI as a service. So this is the this is the interface that we have for bringing in the data. We'll see in the demo more clearly. Like you can have a file upload from your own computer. Like we had those files in the Google Drive, you'll download them and then finally upload them to the platform and then make use of them. Then you can have external buckets on your cloud, like S3 bucket or a GCP bucket. Then you can have streaming data set. Like somebody might have, like streaming data set is like real-time incoming data set. Like you know of Netflix, all these are streaming services. And then they have live data coming in and live recommendations being generated. So that is what is streaming data set. Then we have these connectors as well, like Snowflake and Salesforce, which you can use, BigQuery as well. So you have the flexibility to utilize a lot of data sets if needed. Data augmentation. So the modular approach that I already discussed about, it's the same thing, but in a different context. Like dataset augmentation is one module that we have. Training and testing is one module, explainability module. So this sort of approach helps people to abstract things in a modular way. For example, you might be interested in explainability. You already have some infrastructure, you already have predictions, but you don't know what those predictions, how those predictions are generated, like how the model decides that this is the prediction to generate. So you need this explainability module. So that's where this comes in handy. If it's modular, if the infrastructure is modular, then you can just plug in this module and make use of this on your existing thing. Same goes with data augmentation. Okay, now comes the data cleaning part. So data cleaning, as I said, is a very important step, and it's quite cumbersome. So this slide is actually showing one of my notebooks and I'm trying to tell you how cumbersome it can get, especially if somebody's not hands-on, or if multiple technologies are getting used, the technology stack is changing. So yeah, so the whole idea is trying to tell you that without proper tools, it can get really tricky if you're trying to do this on your own and if you're not an expert in some technology stack. So today we'll see how, without writing any complex code, how we can achieve the same results and how we can prepare effective features to feed into the machine learning model. This I've already explained to you, what these graphs stand for, the dependent columns between the target, and then how to ignore them to train the model. Then the important scores, we have discussed all this. Data augmentation, I've already told you. It's just sometimes when you have less data, then you might want to augment that with some additional data. For that, what you do is utilize some technology that can mimic the patterns that are existent in your data, and then push out some sort of data that has same sort of patterns. So you would have a lot of additional data, and then with that increased data, you're likely to train a better model. So that's the whole idea of data augmentation. And GANs, like, as I said, we are a deep learning first company, and everything that we do is somehow connected to deep learning. So generative adversarial networks are the ones that are being utilized for doing this augmentation on our platform. Model testing and training, we already saw the splits, hyperparameter tuning, everything. Explainability. Okay, so I won't go much deep into this, but yeah, explainability is like an entirely new or different machine learning model that is trying to understand the functioning of an existing neural network. So what happens is, looking at the prediction, the model kind of tries to understand why the first neural network predicted that. So, so there are different methods to do that are based on different sort of ideas, like game theory. So one of the methods is Shapley, and that's what we utilize on our platform. So if you're interested, you can visit the YouTube channel that we have, and you can have a look at the workshop that I gave on explainability, where I explain all this into great detail, Okay, one final thing here. So in that one slide that I had about all the concepts that will be required to go through the demo successfully today, that had something called AutoML. So AutoML is quite hot these days, and a lot of research is being done on that. One of the AutoML techniques is neural architecture search. So we have this technique being incorporated in our system, where what happens is, in order to tweak those hyperparameters successfully, there's another neural network that is being utilized. So that second neural network, it does what? It kind of searches for different architectures and kind of tries to see which architecture is the most suitable for the given data set. So it's like finding the most optimal neural network architecture that is being performed by another neural network. So that's the whole idea of neural architecture search, like automation at a second level, training with less data. So this is another principle which is quite interesting. A lot of people are doing their research on meta learning, and it's going to be very beneficial if we have some success there. So what essentially happens here is, a lot of times you don't have a lot of data to start with, and that creates problem. That doesn't allow you to generate quality predictions. So for dealing with this, sometimes humans sometimes are way better when the data is less to predict the final outcome. So what happens is, their understanding of the domain makes them better, which the neural network essentially doesn't have because of the lack of data. So the network learns from the data, but since there's not much data, so that's why the network is not so efficient in understanding the domain, right? So what happens is people come up with various ways to incorporate that domain knowledge into the network without having to give the network a lot of data. Like there are some logic rules that, okay, if this happens, then do this. So these kind of logic rules can be embedded into the neural network so that the network also gets some domain knowledge, and it kind of handles the situation depending upon the domain knowledge that is being embedded into the network. So it's another very exciting thing. Explainability, you already know. I explained SHAP. Neural architecture search, you have the high level idea. So on a more deeper level, there's a search space, there's a search strategy, and there's evaluation method. So in the search space, what happens is there are like, let's say 10 to 100 architectures that the algorithm might pick. And then this consider that as a search space. And then there will be some strategy to pick the best architectures from that search space. That strategy might be based on some reinforcement learning, some sort of Bayesian optimization or evolutionary genetic algorithm. So depending upon the strategy, that search space will be used to come to a set of architectures that are best suited for that data set or set of data sets. And then finally, there will be an evaluation method so that we can test how good of a pick we have. Like if we have picked, let's say 5 architectures to ensemble means like clubbing those 5 neural network architectures into one. It's like averaging the predictions of the 5 networks, in short, that's how ensembling is. So let's say you have picked 5 architectures to ensemble, then the evaluation method will just go one by one on those 5 architectures and will evaluate them to see if they really are the best 5 or not. So there's evaluation technique as well. So this is like a very high level idea that I'm giving you. But if you really are interested, then again, you can go to our YouTube channel and there's a AutoML workshop that we have. You can find more details into how search space, search strategy, and evaluation methods work. Explainability, we have already gone through that how these are the most important features that contribute the most towards the prediction. So it helps in white boxing the model. White boxing means these neural network models are basically categorized as black boxes. That means you never know why the network is making the prediction, whatever the prediction it is making. You never know the reason behind that prediction. It's like, so there are a lot of white boxing techniques. That means there are a lot of techniques that kind of focus on getting a sense of the reasoning behind those predictions. So I mentioned Shapley. There are other like Lime, anchors. There are a lot of other techniques that are used to achieve those things. Okay, now you know the basics, like you know what AutoML is. You understand the key metrics that we are going to use. You understand what is deployment and what are the steps to train the model, get the data right. So I think we are in a good position to start with the demo. Okay. So I'm just having a look at the time, 1:47. Okay. That's perfect. I see a lot of things in the chat here. Okay, I'll take them one by one at the end for sure. We'll have a lot of time at the end, I believe. But yeah, let's go towards the demo because maybe a lot of things would become clear after this demo. So I would not have to address them explicitly. But yeah, if we need, we would definitely take this after the demo, whatever is left. Okay, so let me start with the demo. So now open this Colab notebook, the link I've already shared. Let me share this again. So I've shared the collab notebook link again. Open this link, and here you would have all the useful links that you would need. Okay. So let's start by signing up. Click on the sign up. So you see I'm already in because I already signed up, but I'll just log out and sign up again for you guys to follow step by step. Okay, here it is. So once you click on sign up, you'll see this screen. Now you can enter any email that you might have. An 8-digit password. So in uppercase, a special character and 8 digits are requirements for this password. And then once we sign up, once we click on sign up, it will ask for the verification code. Oh man. I'm not sure why is it asking. Actually, it doesn't really ask. Okay. Let me do the verification. Somehow I've already registered using all the emails. Okay, let's try this one. This also exists. No problem. Okay, now I'm in finally. So organization name, that's your organization name. Like you can put in your name. If you can even leave it blank, that will take in your email ID by default. So whenever you sign up, you create a container. That means you create a place where you can keep all your machine learning projects. So that container, I'm just calling it an organization, because you might think of it as like a team activity where your team is working on a machine learning project, and you have some members you can add into your organization or your team by using this, and then you can have your connected services from where you wish to bring your data. As I already showed you, AWS, S3, BigQuery, all that stuff. This is the API section. I told you how you can integrate with your web application and stuff. So this comes in handy if you want to do that. But for the purpose of this demo, we would be simply creating a new project and then starting to train our model. So for that, just create a new project. Select predictive modeling. Let me bring the chat in order to see if anybody has a doubt or it's all clear to everybody. Following so far. Yeah, recording is there. It will be available on our YouTube channel right after the workshop ends, so don't worry about that. Following. Okay, thanks for the clarification, for the message. Okay, so on this page, so these are these small, tiny question marks. Later, if you are playing with this platform, you can like utilize them. If you get stuck somewhere, this will tell you what that thing stands for. this will help you like move along. We call it in-product help. Okay, so as we discussed today, our focus is going to be a predictive modeling predictive modeling solution. So that's the solution that we are going to choose. Continue. Give your project a name. So insurance prediction, since we are predicting insurance price, you can just name it as you wish. So this is asking you for a target variable. So as we saw in one of the slides, how we have to tell the system, we have to point the system to the inputs and the outputs, and then the system maps them together automatically. So this is where we do that. Like we can write here something like insurance price as our target variable, and then it will ask you some features that you want to name. But for now, since in our data set, we have all the column names already, we have the target variable set, we can for now just skip this. So this is the interface that we'll use to upload the data that we have here, these data sets. So let's click on create dataset, create new. So these are the explanations for what is the schema required for this data set. This is the example showing how you can use, what kind of data set you can upload here. So let's click on create new. Name, let's give it the name insurance dataset. Okay, so go to this Drive link, download the dataset. Go to this, go back to the project, just drag it here. Somehow it's not getting dragged, what? Okay, somehow it's not getting dragged. So I'm gonna use here. Insurance cost. What is the problem? Why is it not coming? For you guys, are you trying? Did you upload it and is it successful?
Try renaming the file to CSV.
Yep, that's what I'm thinking. Okay, you're right. Somehow when I downloaded it from the bucket, its extension is not CSV.
You're not letting it add CSV. So when you add CSV, it asks don't add or add. You press don't add.
Oh, it was not the name.
So you can extend, you'll have to add .csv. It's not renamed yet.
Yeah, I clicked on
add.
Ah, I clicked on don't add. You're right. I was thinking in my mind, I'm clicking on add. Ah, sorry. That's what I was thinking, like, why didn't it get renamed? Okay, so here we have our CSV files. Let's just drop them here. So this is the primary data set. So this is the primary one, so we'll drop it here. Now it's going to process. We'll add the second one here. Second one is health. So for you guys, you just have to go here and download this. And then again, you would have to rename. Sorry, my mistake. So you would have to do that renaming yourself. Okay. And then once you have done that, we'll go here, upload it, add. It's processing. It's asking you to wait. Cool. I'll just open another instance. Click on here. So now the next item, the next thing that we have to do is to map this data properly into the system so that the system can identify what sort of columns are there and map it according to the use case that we have. So let's do it. Click on resolve. Okay, so this is done here. So we can go to the same page by clicking here, explore plus train. Again, it will ask to resolve, so click on resolve. Yes, but I have to rename to CSV. Okay, yeah, cool. So now it's asking for the target variable. So we have to predict charges. Continue. Join key. So as you see, there are two tables. So it's asking the primary key thing. That's C0. Confirm. So this interface is populated now. If you go back to the main page, you will see that it's telling you that, hey, now you're ready to train the model. I'm loading. Okay, yeah. Yeah, I'll wait for you guys for sure. So your data set will come here in this list once it gets processed. Your schema will be populated here. So if you change the schema, then a new version is created. That's a new thing that we have introduced recently. Missing required columns target. How to resolve that? So just go to that drop down and select charges as your target column. The free trial doesn't expire like that. You have like the capacity to train 2 models under this free trial. But yeah, if you're interested, you can ask me and I can probably give you more number of models, increase your limit if needed. Okay. So by the time I'm waiting, let me explain to you a few more things. In product help, I already told you, you can always utilize this. What is a column mapping? So there are like target and ignore. There are 2 mappings for this particular predictive modeling use case. Target means the target variable, which you want to predict. So it's a regression model. It regresses the value of charges, which is the insurance charge that we have. Second is ignore. So we'll come to this ignore part. Ignore means just ignore this column from training process entirely. That's what ignore does. Like there might be some column which is very correlated to the target, as we saw right in that graph. So you might ignore that. So it comes handy in there. So these are the data types: categorical, numerical. Awesome, nice. Okay. So numerical is like in mathematical terms, any value that is bigger than in math, if the value is bigger, then the same logic applies to the feature. If you want to keep it like this, then you have to select numerical. So if we go and visualize the raw data, see 19, 18. 18 is a younger person than 19. So this value is smaller than, I have only 2 columns, BMI and smoker. Okay, so here the schema of health is this. So you have 2 columns there and the join key. Insurance data is the second main data set that we have. For that, the target is this, and we have all these columns. So you can switch it using this switcher. Okay, you can make sure that your data is correctly uploaded. Custom column, insurance data, secondary table, health data, and they're active. Yep, we'll come to that point. What is a join key? So let's try to make sense of this data first. So in insurance data, we have this identifier. Then we have this attribute age, sex, children, region, and then the insurance charges for that, for all those parameters, right? For health data, we have the same column identifier that will help us map to the first table. And then we have the BMI and the smoking, this parameter, whether the person smokes or not. So these are the 2 attributes for this secondary data set. So in order to map, we use this join key on this column C0, right? So now you might have already understood what a join key is. So it's just a join table, like an SQL left join. You may also get to this. When do you standardize or normalize the data? Correct. It's a shared index between tables. Here we are doing a left join where the primary table is the left one. So all the indexes in the primary table are being taken and joined to the secondary table. And that way, you have like those 2 additional attributes joined to the first table, right? How to sort out the error missing, required column, target, and dataset custom table. Just drop down, as I said. From that drop down, just select charges, and it will populate. You just have to click on that drop down and then select charges, because that is your target. You're basically calculating the premium charges for the insurance. Okay. Okay. So now we know what this raw data is, how it looks like, what it means. Now we're completely familiar with the domain. Let's move forward. So this is another cool thing. You have the value distribution, so you can quickly visualize like how your values look like. Your BMI starts with here, 21, 22, goes all the way till 53, which is really high. And then this is the average, minimum, maximum sum, smoker, 2 values, yes and no, right? Same for insurance data you can use, right? Age, male, female. So this helps in like quickly understanding the value distribution and the probability distribution, CDF, VDF, that sort of thing for data scientists. Data prep. So this is the feature engineering part. Okay, so let's first train a model without feature engineering. So you can just do like, you have your data populated already, right? You have explored the data. You can just go here to this page, or you can go to the main page here and click on train model. Okay, like this. You can name it if you want. Insurance prediction model, by default, it will give train model. So we'll start training the model. Can you repeat please once? Yeah. You just have to click here. That is your like main project page. And you just press this button, it will start training your model. So if all the preliminary steps are completed successfully, this button will be activated and your process of training will begin. You just have to click OK on the dialog boxes. There's nothing further. Like as soon as you click on that box, this interface will pop up. You just click on this and the training will begin. Okay. Okay, now let's go back to the feature engineering step. Okay, nice. Okay, so let's say we have to add a custom column, like we want to create a new feature or something. So we can click here. We can say whatever you call, whatever name you want to give to that feature, that column. And then you can write your SQL query. So let's think of something interesting, like I will open this tab in this interface in a new tab. Yes, no, it's a numerical. So if you go to this value, you see this is like some charges. So this is a numerical value. Yeah. So that's why I said it's basically whenever you train a model, you should visualize the data first. The raw data as well as this data exploration. These are the two tabs that you should use to visualize the data. Once you have the schema right, then yeah. Because until you make proper sense of your data, you won't be able to train a good model. Okay, so I was demonstrating how to add a custom column. So we'll go here to the schema. We'll add a custom column to the schema. Click here, give a column a name. So do this. On one tab, you have opened this thing. On the other tab, open this raw data. Just press Alt if you're on Mac, like the Command key, or if you're Windows, then Control, and then open this new tab. Now, let's think of what sort of new columns we can make. So what we can do here is we have BMI on the second health data, and we saw there are like crazy high values for BMI. So we might create a new feature saying that if BMI is higher than 40, let's say BMI is higher than 40, less than 50, and the person is a smoker, then let's create a new column risk and make it high, like 1, which means high risk, otherwise low risk. Because if the risk is high, then probably the premium cost is going to be either too high or the person won't even get their insurance, right? So such feature makes sense in this case. So you can think of making a feature like this, right? So I'm just giving you ideas on how like you can do feature engineering. So depending upon the context, depending upon what you want to achieve and the scenario, you should think of like the required features that would help the model be more efficient in getting the results that you want. Okay, so let's just stick to the idea that we just discussed and prepare a new feature. Risk. You can copy paste from here, making it easy. Case when, what is the column name? BMI. That's not good. So generally what it does it, okay, now I get it. See, BMI is in health data, and here we are in the insurance data. So that's why it's not giving you BMI. Okay, so you have to make sure you're in the right schema. So go to the health data set, then add a custom column, make it risk, and now paste. Cool. Case when B, see now it populated. So that's why I was like, why is it not populating? Because you are not in the right schema. Okay. So this is another cool thing. Like it gives you an autocomplete thing. So we decided to make it more than 40 and less than 50 and smoker equals to, what was smoker? Yes or no, or 0 or 1? Yes or no, right? What happened to my keyboard now? Sorry guys, something happened to my keyboard. Okay, now it's working. Smoker equals to yes. Cool. Okay. Now let's preview this. Giving me some error. Mismatched input BMI expecting. Cool. So you see there's an end that is required. So case when this and this, and there's condition. So I was trying to tell you that if you get it wrong, then the system is going to tell you. So it's helpful. The system is really helpful here. So do what? When case is this, then risk, this column you're creating, this risk one, it's 1. Else 0, end. Click on preview. Cool, successful. Giving you zeros. So it doesn't give you all the points. It just takes some random points and gives you the output using your query, so that you can just verify whether your query was applied and you got results or not. So this query is correct. It's being applied properly. We can just add it. Cool. So we have a new feature called risk. And then we have this query corresponding to this new feature. And this new column will be automatically populated for you and utilized during the training process when we will train a new model. So you can do more, like if you don't need now these features, you can ignore. And then you can only utilize this, or you can just keep all of them. So we're going to just keep all of them and see what happens. Okay. So this is another cool feature engineering step. Number your slides so that we can refer to them unambiguously on the slide in the demo that says expected data. There's a typo there. Oh, cool. Yeah, that's a useful suggestion. I can definitely do that. Okay, cool. So now we have a custom column made. We can go towards another cool feature, which is filtering. So sometimes what happens is you might want to filter something, like include or exclude some column depending upon some criteria or condition, right? Like if age is equal to 0, color not in red. So filter all those columns, right? So that's what you can do. Like for example, I want to write something like anything you can do. Like just think of like BMI greater than 40, filter exclude that if BMI greater than 40. So anything you can do, any sort of thing you can do using these include and exclude filters, right? Like let's say the region when it's south, let's see how many regions are there. So region, sorry, it's in the insurance data. Here, southeast, northeast. Let's just ignore southwest for some reason. Let's say we don't provide insurance in southwest. So exclude region equals to something is wrong with my keyboard. I think the battery is dead. Sorry. Southwest. Cool. So it's giving me now those columns that have this region. These will be excluded. Save. So we have a new exclude filter. It will be applied to the data set. And then next is training the model with our new features engineered properly. Train model, automatically giving a name. Train model. Sounds good. Okay. So now the second model is getting trained. The first model is trained already. So let's move on. For you guys, it might have already trained as well, but if it's not, then just wait and follow me. Click on that. You'll get to this page. Or just simply come here on the metrics. Click here. You will see something like this. So these are the metrics that we talked about. MAE, WAPE, WAPE, RMSE, and the R-square, coefficient of determination. If you want to read on them, you can do it here. But I've already explained to you the mathematical form of this, the meaning of COD. Okay, these are also almost the same. The mathematical forms are definitely different and they resemble something else. That's why the values are larger as compared to this. But yeah, there's something that you need to keep in mind. That is like the ideal values. And if like a higher number is better or not, these two things that you have to always keep in mind, at least. Okay. Like for coefficient of variation, the range is 0 to 1. 0 means no variation in the target variable. 1 means full variation, such that everything is dependent on this column, right? So this is the metric dashboard, and this is how you evaluate your model. You see whether your baseline, the metrics, when you compare them with the baseline, are they improving or not? And if they are, then how much, by what percentage? So here we can clearly see a lot of improvement. And then you can even go for feature importance scores to see like whether it makes sense. Like smoker has a high contribution, age has a high contribution. So somehow it makes sense. And this is another new thing that we have introduced, predicted versus actual. So using this graph, you can like make sense of the differences between the actual values in the model and the values that the model predicted. Okay. So now let's get to the final step, which is deploying the trained model. Click here. As you can see, there's nothing because there's no deployment that we have created yet. Create new deployment. 5 calls per second is fine. Okay, so the model is getting deployed. So I already explained to you what deployment on a high level means. Once the deployment gets activated, then we would be able to go to the prediction dashboard and see all the predictions that the model is making. We have already discussed everything that is there in this predictive modeling, except this API and batch prediction. As soon as these interfaces get populated, we could definitely discuss them as well. It doesn't take more than 3 minutes. Sorry. Let me quickly. Okay, so this is another project that I've kept in another organization. So we can, and here I have already deployed the models, so we can use them to save time. So this is how this deployment will look like. So this is the test data we already discussed what test, train, and validation splits are. So predicted value is coming to be this. Actual value is $3,900. So if you see, this is like just a sample data. It's like a very small data set. So still the accuracy is not bad for the size of the data set, I think. This is the explanation, the Shapley values. Like, what are the most important features for this input point? So remember, for this point, this data point in the data set, these values. So these values only stand for these, only stand for this point, not the entire data set. So for example, if you choose a different downloadable software, will the recording be provided? Yes, the recording will be there. Downloadable software. I'm not really sure what you mean, downloadable software. Like you can't, so this is the web, this is AI as a service model. So it's a web service. So it runs on this client. Okay, so Power BI desktop, nope. We don't have any desktop application associated with this yet. So you can select any point from this. Now you see these values changed a bit. Still smoker is most prominent, but the value, the contribution score changed a bit. See here, the contribution score changed. Second is now not age, but BMI. So these are like local scoped values, Shapley values, based on the sample data point. And when you see in the metric section, this graph, this is showing the global, like for the entire data set, for the entire test set, what are the most important feature contributions? So this is like averaging all the values, all the local values to make them global and show you and give you a sense of like what is the most important feature. But here you can visualize them point by point. Okay. So now you understand prediction dashboard as well. This is the API I was talking about. Using the REST API, maybe a curl format or Python format, you can, okay, authentication needs to be done. So you create a deployment token by clicking on this button. Is there a reason you're, yeah, because this is in the workshop, Abacus.AI workshop organization. So if we go back here, our predictions would be the same because we have trained the same model basically. Still getting deployed or what? Okay, so this deployment is active. If you go to the dashboard, this here we will match here because we have trained the same model, but there I might have taken some different features. So that's why the predictions are different. Okay, so going back to the prediction API, create new token. It's an authentication token. Now it's showing you the result in the JSON format for this query. This query had all your parameters, attributes from the first table, from the second table, deployment ID, authentication token, 3 minutes, 4 minutes, not more than that. Okay. Batch predictions, just provide a name, start. So it will take all the data, batch it, generate predictions, and then give you a file that you can download. So you will have like a CSV file that has all the predictions. So you can have like different options here. Like if you don't want to batch, you can specify a list of IDs here, and only those IDs will be batched. You can upload your file that might have some IDs, and those, and that will batch predictions will be generated there. Is there a way to know what the service cost? Oh, sorry. So so I myself am not sure, but yeah, there's a definite web page that has the price description in detail. I'll this time note your name for sure, less guessing. Just pass me your email ID and I'll give you the link for that page. Exactly what are the prices. That page will have all the details. Okay, just give me your email ID here. Pass in the chat. Yep, as somebody mentioned, it's basically the opposite. Oh, yes, you're right. So there's a mistake in there. So that's why I got confused during the demo. I was like explaining and I was like, what is happening? Why is it opposite? So just don't mind it. Yeah, what you're thinking is right. Okay, I have your LinkedIn here, okay? So I'll just connect and pass you that info. Okay, so now you know batch prediction as well. Okay, let me save it. Because this time I'm not gonna. Okay. Cool. Cool, I'll pass on to you all. Okay, so I think there's one more thing that I would like to mention before we go. Yeah. So here, there's something called refresh schema. You might have seen it again and again. And the advanced options. Like this refresh schedule UTC. So here what happens is you might set some time, like if you click here, go to this. See, minute, hour, day, month. So you can generate a string, an expression, and you can put it here. Oh man, sorry. Going back here to metrics, to the model. Here, train model, putting here. So at 4:05 a.m. So this string resembles this time. So at that time, this model will be refreshed. That means a new model will be trained according to whatever schema you have at present and whatever data is there into that table. So this becomes useful when your model gets outdated. And that happens because maybe your algorithm is changing, so you want to train a new machine learning model, or maybe your data is refreshing. So yeah, not auto-deployed. Yeah, I mean auto-deployed also, but that comes under deployment stage. So this is the model training. So here it gets automatically trained at that point of time, whatever you mention here. And for deployment also, there's the same. Like you can set that for deployment. You can also set that for dataset, like here. So when you upload dataset, then the option doesn't come. But when you have, like, if you see here's the uploaded file. So if you have this from bucket, so the option will come here, the same refresh. Because what happens is, so here it's a manual scheme. You just put it here and it will upload. But from S3 bucket, if you put it from S3 bucket, then it will automatically pick from the S3 bucket or whatever bucket, GCP or whatever you have configured it to upload the data from. So that's how the refresh schedule works for dataset upload. So that's another cool thing that everybody should have on their service. And then final thing that I would like to bring is the advanced training options. So I showed you the cake layer, and I also showed you the modular structure. So for ML engineers or data scientists who are interested, they might utilize these advanced training options and play with them. Like test split, you can change it to 15% instead of 10. Dropout rate, you can change to like what, 30%. So a lot of people are familiar with this in terms of like 0.2, 0.1, because that's generally the case you see in the literature. So don't get confused. It's the percentage here, 0 to 100. Batch size, you can manually select. We discussed about batch size, the pros and cons of high and low batch sizes. Right, there are some other advanced options. Like you might have some sort of sampling unit keys. Like for example, there's a sensor, and that gives a lot of values in 1 second. So you might want to club them. So that sort of things can be done using sampling unit keys. Like you can club those values and create a primary key, sort of like a key, and then the entire row will be considered as one. Do you have validation, cross-validation? Yeah, those things are taken care of internally. So externally, we don't have to do anything. The data is split, there's stratified sampling and every sort of thing that is being taken care of inside at the back, so that your data is properly split and has all the IDs and all the splits. There's rebalance classes. So you might have one rare class, and you might want to have good predictions on that rare class, so you can rebalance the class. So there are some cool features that you can play with and train some new models using these settings. Yep, so that was the final thing that I wanted to share with you all. And I'm really glad you suggested me all those things. So I'll be like numbering the slides. I think it's really beneficial so that we can later refer with the number. And yeah, keep that in mind about that. A dependent and independent variable, that's for sure doesn't make any sense. The target is the one that is independent. So you should, yeah, correct that. In the slides, you have all the links. So today you learn how to bring the data, how to do feature engineering without writing any code, which was something useful for people who don't want to write much code. And you trained a deep learning based model. You'll learn how to tweak those advanced training options to an extent. Then you finally learned about deployment. You evaluated the metrics. How can we delete or add columns after the model has been trained? So as I showed you, once the model is trained, where is the schema? Here. You can delete this, or you can go to the previous versions. See here. Your previous schema versions are recorded in the system. It's a cool feature that we have. You can even export your schema in a file. It will be downloaded below. So yep. Okay, let's see. So yeah, finally you learned, like I'm just reiterating, how to evaluate your predictions, how to visualize them using the prediction dashboard, and make proper sense of whether they're of high quality or not. And then finally, I would want to share these resources that you might want to refer to if needed, like our website, our documentation and tutorials, a blog, and then our YouTube channel, which has the links to all the past workshops, like my explainability workshop and the AutoML workshop that I briefly mentioned about. Okay. So yeah, if you guys have any questions, let me know. Right now is the right time to address them. We still have like 20 minutes. Yeah, it was really a pleasure. Hope it helped. Is it possible to generate codes? Well, the internal machinery is abstracted and you don't have access to the code. You have access to the APIs and the results using them, but not the code. If you're interested in the underlying algorithms, then definitely read the blog and go through the past workshops. You can even shoot me an email. Ankit at Abacus.AI. It's mentioned in the slides as well. Pricing link I'll send you. All those who have given me their emails, I'll just CC them. Let me read the questions if there are any left. R-square, we have already taken care of all that. Downloadable software. Join key, all this have been addressed. Enable all files and upload option. Will the recording, this recording is being done. It will be available in a few minutes after the end of the workshop. Online GPU resource with 64 GB RAM for executing code of deep learning model like transformers. Online GPU resource, yes, Google Colab. So I've already shared that notebook. That's a fantastic resource. You have like what, I think P80s or something, not P100, this K80. They have one K80, you will get a part of it. It might have like 11 gigs, I think. And it also has like a lot of RAM in there. So you can connect and utilize that. It's a very good service from Google. Can we decide with this graph that how much data is correlated? Yes. So that graph that I showed you, that shows the correlation and gives you automatically the column names that are highly correlated and should be ignored. So definitely you can utilize it. Alpha random number small, no formal way for alpha. I'm not sure what exactly you're trying to say here. Is there alpha random value to start with, or does it have a formal way to arrive at a value? I'm not really sure in what context you're talking about this random number. If you're saying, so neural networks, so I told you that in the beginning, the neural network is like starting from any random point. But in reality, there are some heuristics. Like the points that a neural network start with are not arbitrary. There's something like H1 initialization, hue initialization, some sort of initializations. You can read on that online. There are a lot of papers on these initialization heuristics. And that's how, with proper initialization, you get better results. The network gets trained in a better way. Because if the initialization is wrong, if the point is too random and lies like very far from the actual points in a very random way, then sometimes it gets hard to train to get the network trained properly. So the initialization is an important thing. And depending upon a lot of things, like if you're using ReLU, then the initialization changes. If you're using 10H nonlinearities, then the initialization changes. There are a lot of loss functions to choose from, of which we have gradient descent. Yeah, yep, you're right. Like I showed you that advanced option, advanced training option, rebalance classes in predictive modeling under regression use case, right? So there's a focal loss from Facebook in 2018. That paper came. So you can read that paper. There's a focal loss that is actually implemented that takes care of rebalancing and stuff. So yeah, there are a lot of different kinds of loss functions. Yep, there's alternating least square loss that is used in recommender systems a lot. Hyperparameters. Yeah, hyperparameters are like those tunable parameters in the neural network, like learning rate we saw, dropout. So dropout is like you have these neurons connected to each other. Randomly, you would disconnect some of these neurons from each other. Like let's say, so my slide is still shared, right? My screen is still shared. Let's go back to that slide. So here you see these red points. So randomly they're dropped. And now there's like a different structure of the network. So at every iteration, some different set of neurons will be dropped. And then the network will be trained in such a way where it's able to like generalize better. Like the dependency of these neurons from each other becomes lesser and lesser. They become more like independent in identifying the patterns. So that's what we need for better generalization. So that's why sometimes a high dropout rate is needed. It makes regularization possible. So yeah, regularization means just like the way I said, to make it more generalizable, you need to follow some techniques. So that's what is a regularization technique, dropout. What else? Can someone repost the link with the information about PDF, datasets, etc.? Yeah, the Colab. So at the YouTube recording, in the description, there will be a link to the Colab notebook. So if you miss it by any chance, I can share it again. But for those who might have missed it, they can fetch it from there as well later. I think that's the end of the questions. Let me see. Does the explainability module show path taken, which neuron involved in details at explainability module debugging, show path taken, which, oh, you mean that? No, so path taken, like what are the, okay, so you might have seen those diagrams like in image processing when they feed image to the neural network. Sorry. What they do is like, they show you what are the different parts of the image. There's a big giant grid of images and what are the different parts, and they show you the parts of the images that are being activated, right? Depending upon the output. So, so what they do is like, so you can read on that, like there are different techniques, but it's not, it is not like, you can't make sense, you can't find entirely what are the pathways that are being activated. You can just see in the image what are the areas, but you cannot find exactly the pathways. What else? Let's see. Okay, I think that's it. Okay, I think that's it. After building one model, can we automatically generate other models using the same specifications? Yeah, definitely. Why not? You can just click on the trained model and then a new version of the model will be trained. Specifications will be the same. Let's say you have some new data rows that came in. Then yeah, all the specification of the schema will be the same, but those new data points will be taken care of when you train a new version. Okay, so I think that marks the end of our workshop and the demo. A different model, not the version. Yep. So for a different model, so a different model, not the version. I see what you mean. So, okay. So when you retrain, then a version is created. Let me go back there. Like this is the model list. If you click here, then the version will be created. But if you go here, then it will be an entirely new model that will be created. So definitely you can train as many models with different configurations here, with different schemas here. And then, yep, you will get a variety of different results from those different models. And they will have their own metric page like this. This is a different model, this is a different model, this is a different model. And then this model, if there was a different version, let's say if I retrain this, there will be a drop down here. And then you would be able to select a different version for this one model. Okay. So whenever you have here, you go here, see here, it's showing you version here. So for this model number or name, there's a different version. And these are the versions of the data sets that are tied to this model. These are the schema versions that are tied to this model. I showed you how schema versions are being tracked, right? So yeah, you can like play with the system and understand this all. And if you have any queries, definitely shoot me an email. Yep. Yeah. Yeah, I will update the Eventbrite post with the recording link so that you all can watch it. Just one more thing. Is it possible to visualize the architecture of the final model created? architecture visualize? No, unfortunately not, because there's no like way to know what were the values. Like we don't output the hyperparameter values or any specific details of the model itself. So it's all internal. So no, you can't. You can visualize the results. You can visualize the predictions. You can visualize the graphs using the graphs, all these outputs, but you can't visualize the architecture of the model itself. Like in a business context, people don't usually care what the architecture looks like. So that's why. Okay, so if there are no further questions, I think it's time to end this. And I hope you all will make the most of your time and stay safe. And I'll see you all in the next workshop. How do you present your result? I'm not sure what you mean. Like, I'm new to deep learning. Any advice how to learn it fast? Yeah, there's so many. There's a plethora of online resources. There's a YouTube channel by Josh Stammer. I like his content. You can go there. There's this the name of that channel is StatQuest, and then there's this Fast AI course. There are a lot of courses on Coursera, so you can go through them. And then definitely this platform, Abacus.AI, you can play with the data from any public data source like Kaggle, and then you can analyze your results quickly using the interfaces that I showed you. So definitely you can play using the system. Is there any option to send this result to end user co-team member to check for? Yeah, I showed you the batch prediction, right? You can batch predict all the results, get a CSV file, show it to whoever you want. And if you want the metrics, you can download the scores. If for some reason, yeah, you can download the scores, and then you will have a JSON format, a file in a JSON format, and that way you would be able to like show the results. You can just like snip this if you want these graphs. That's also a way. Yep, prediction dashboard. Oh, I see new data. Okay, so here, create a new batch prediction. I see what you mean. That's a nice question, yeah. Upload file. You'll have your data here. It will batch it. It will run the whole thing there. And then it will output the file with the prediction. So that's where batch prediction comes into play. Like your new data, utilize the model on that, and then get the predictions batched in a file. Same with this API. Feed, like I showed you, right? This query. Here you would feed your data, and then it will produce the result. So if you know how to utilize APIs, then you can adopt this pathway. Like we have a documentation center. Click here. There's a tutorial section. These are the notebooks which open directly into the Colab. So you can just run this on your end, and then you can get to know. You can basically do all the things that I've showed you using this API, SDK, Python SDK. Can I generate a web link to pass on to other person to test new data? Unfortunately not. Web link, like for them to be able to generate, they will have to come to the Abacus.AI platform, and they would have to access your organization. So either you give them your password or make them a team member, as I showed you. Like you can add, like I showed you, right? Here you have option to add people to your team. So add them, and then they can access this. And then, yep, they can also do the things that you have done. They can have almost everything, access to everything that you have. Okay. I think that is it for today. Have a really good day, or good night for some people. Hopefully it was helpful. You learned something, and hopefully you got excited to learn something further. Okay, then it's a goodbye for now. See you later. Bye.